Dear students, welcome to the class. I am Dr. Tirupathi Reddy, Department of Mathematics, B.V. Raju Institute of Technology, Narsapur. In this linear algebra and calculus course, we are going to learn about problems on finding Jacobian. Let us see problem statement. First problem, if x is equal to r cos theta, y is equal to r sin theta, then find Jacobian of x comma y with respect to r comma theta and Jacobian of r comma theta with respect to x comma y. Also show that you label this as j dash, j into j dash is equal to 1. This is what the problem statement. We have to find out the solution by using the definition of Jacobian. So what is given here? X is equal to r cos theta, y is equal to r sin theta. So here x and y are dependent variables, r and theta are independent variables. Okay. So we can find the Jacobian from x comma y to r comma theta because dependent variables are expressed in terms of independent variables. So Jacobian of x comma y with respect to r comma theta is defined as determinant of a 2 by 2 matrix, it consisting of dou x by dou r, first row consisting of first dependent variable, partial derivatives with respect to all possible independent variables, dou x by dou theta, dou y by dou r, dou y by dou theta. Second row consisting of second dependent variable, partial derivatives with respect to all possible independent variables. So before to substitute the values, let us compute them. Dou x by dou r, you are differentiating r cos theta with respect to r, cos theta will be treated as constant, r derivative with respect to r is 1, and dou x by dou theta, so we are differentiating x with respect to theta, r will be treated as constant, cos theta derivative is given by minus sin theta. Similarly, dou y by dou r, taking y r sin theta and differentiate partially with respect to r. So sin theta will be treated as constant, r derivative with respect to r is 1, and dou y by dou theta, in this r sin theta derivative is cos theta and r is treated as constant, we will get r cos theta. So therefore j is equal to Jacobian of these two functions with respect to r and theta is determinant of cos theta minus r sin theta and r cos theta determinant. So for any matrix ABCD, its determinant is obtained by taking AD minus BC, cos theta and cos theta multiplied here, we are going to get r times cos square theta and minus into minus plus and r times sin square theta. Upon taking r common, it remains cos square theta plus sin square theta. This is forced to 1, therefore r into 1 is given by r. So therefore we got finally Jacobian of x comma y with respect to r comma theta is r. Similarly, we have to compute the Jacobian j dash. So here numerator consisting of r and theta, these are dependent variables, these are independent variables. So dependent variables has to be expressed in terms of independent variables. But if we look at the problem, x equal to r cos theta, y is equal to r sin theta, here x and y are expressed in terms of r and theta. But in order to compute j dash, r and theta has to be expressed in terms of x and y. That is the reason we are going to take them and we are going to compute r and theta in terms of x and y. So given x is equal to r cos theta and y is equal to r sin theta, so from these two we are going to compute, upon taking x square plus y square, we are going to get r square cos square theta, and if you take r square common, it remains r square sin square theta, and this is forced to 1, this is nothing but r square. So therefore, we got one relation, r square is equal to x square plus y square. R square is equal to x square plus y square. That's how r is expressed in terms of x and y. Similarly, you take these two equations x and y and divide one from the other. So I would like to perform y by x. We are going to get r sin theta divided by r cos theta. Both r and r will be cancelled. It remains tan theta is equal to y by x, and we are interested in theta, therefore it will be tan inverse of y by x. Okay. So finally we got two relations in terms of x and y. So r as well as theta. Now for them we have to compute the partial derivatives. In order to get the partial derivatives of r with respect to x and y, take this r square definition and differentiate on both sides. So you label this as some equation 1, this as equation 2. So differentiate equation 1 with respect to x and y. We get r square derivative is given by 2r, and r is a function of x and y. As far as concerned to x and y, r is dependent variable, therefore we have to take inner function derivative as dou r by dou x, and it is equal to x square derivative is 2x and y square is independent of x, therefore free from x, treated as constant, and constant derivative will be 0. And from this we are going to get dou r by dou x is equal to x by r. Similarly, we have to differentiate with respect to y. We are going to get dou r by dou y is equal to 2y, x square derivative will be 0. This 2 and 2 and 2 and 2 will be cancelled. We are going to get dou r by dou y is equal to y by r. Okay. Same thing can also be written as dou r by dou x as x definition is r cos theta. I can write r cos theta by r, it remains only cos theta, and r equivalently dou r by dou y is equal to y is given by r sin theta divided by r, it remains only sin theta. So we have to make use of these results in the future in the determinant definition, and theta is given by tan inverse of y by x. So from this dou theta by dou x is given by tan inverse of x derivative is 1 by 1 plus x square y by x whole square, and in the numerator inner function derivative. We are differentiating with respect to x and y by x derivative with respect to x. Y is treated as constant, 1 by x derivative is minus 1 by x square, and this is given by numerator x square by x square plus y square. I have taken LCM of this y by x square term, and right this here we have minus y by x square. So both are cancelled, it remains minus y by x square plus y square, and we know that x square plus y square is r square, and minus y is given by minus r sin theta. So r cancelled one time, it will be minus sin theta by r. Similarly, we have to compute dou theta by dou y. So tan inverse of x derivative is 1 by 1 plus x square form y by x whole square, and inner function derivative y by x derivative with respect to y, 1 by x is treated as constant, y derivative is 1. Therefore, it remains numerator is x square obtained from the cells denominator LCM, and x square plus y square multiplied with 1 by x cancelled one time. Then x is given by r cos theta, denominator x square plus y square is given by r square. So upon cancelling r one time, we are going to get cos theta by r. Now we have to compute the Jacobian j dash of r comma theta with respect to x comma y is equal to determinant of dou x dou r by dou x as well as dou r by dou y. Dou r by dou x is given by cos theta, and dou r by dou y is given by sin theta. Cos theta sin theta and minus sin theta by r and cos theta by r. So, if you take the determinant AD minus BC, we are going to get cos square theta by r plus minus into minus plus sin square theta by r. So, if you take 1 by r common, it remains cos square theta plus sin square theta. This will be forced to 0, 1. This is forced to 1. 1 by r into 1, it is equal to 1 by r. Therefore, we got j dash of r comma theta with respect to x comma y is 1 by r. This is how we are supposed to compute the Jacobian based on the dependent variables which are expressed in terms of independent variable. And they are also asking to compute j into j dash. So, where j is given by r and j dash is given by 1 by r, then we are going to get, and j into j dash is equal to r times 1 by r, which is equal to 1. So, hence this is how you are supposed to find the Jacobian for any dependent variables in terms of independent variables. Thank you for watching. In the next class, we will see another problem associated with Jacobians. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.